Greetings, class. We are going to be covering additional derivative topics, specifically related rates. In this section, should be able, our objective is to solve related rate problems and applications. So for these types of problems, they typically involve three variables: an independent variable, and two dependent variables. The goal is to find a formula. Find a formula is a big deal. For the rate of change of one of the independent variables in terms of the rate of change of the other one. These problems are solved by using a relationship between the variables, differentiating it or finding the derivative, and solving for the term you want. Let's take a look at the example of a weather balloon is rising vertically at the rate of 5 meters per second. An observer is standing on the ground 300 meters from the point where the balloon is released. So they're giving you the information of 300 meters. At what rate is the distance between the observer and the balloon changing when the balloon is 400 meters high? So let's take a look at how this information plays out. So first things first, you want to make a drawing. So the rate, key thing here is rate, is the balloon is rising at 5 meters per second. So that is like our velocity, right? Our velocity here is 5 meters per second. And the distance of the person, here you are, from where the balloon started is 300 meters from where the point of the balloon was released. At what rate is the distance between the observer and the balloon changing when the balloon is 400 meters high? So here we have the balloon is 400 meters high. That means y is 400 meters. We're going to use x be the distance from the observer to the balloon, and y is the height of the balloon. And so now we have this really cool triangle, right? You have 300 squared plus y squared is going to give us x squared. This is our hypotenuse right here, right? And you can use Pythagorean theorem. We also know that the derivative of a position is the rate of change. And so we know that the balloon is rising at 5 meters per second. So dy dt is 5 meters per second. So here we have this really cool relationship between x and y using Pythagorean theorem. And this is all of the information that we kind of have. Is we have, for sure, we have 300 squared, we have y squared, and we have x squared. So if we take the derivative with respect to t, right, we have x, y, and t. The derivative of 300 is 0 right here. And the derivative of y squared is 2y dy dt. And the derivative of x squared is 2x dx dt. But we are looking for dx dt, so let's solve for that. So we're really just working with this right here. And so you can kind of see we want to get dx dt by itself. And so really all we have to do is divide both sides by 2x. And this leaves us with dx dt right here. And this actually looks like dx dt is equal to 2y over 2x dy dt. And of course those 2's cancel out and we're just left with y over x. Now we need the values for x, y, and dy dt. We know that y is at 400, right, from our previous information. We know that dy dt is at 5 because it's the rate at which the balloon is rising. And so now we have our original equation here. We can find out x, right? From our original equation, you plug in our information. We have y here. And so the square root of 300 squared plus y squared is 500. And so now dx dt is just y over x times dy dt. So y is 400, x is 500, and the rate is 5 meters per second. So dx dt, it is the rate at which this is changing right here, x, is 4 meters per second. So you can see there's quite a few steps. There's quite a bit of planning that has to go involved while you're solving these equations. So first things first, really pay attention to solving related rate problems. You want to make a sketch, which is number 1. You want to identify all of the variables, including those that are given and those that are to be found, given and what you need to find. Express all the rates as derivatives. So if you remember, even though we found what the Pythagorean theorem, we took the derivative of everything, and you had I believe it was 2y dy dt is equal to 2x dx dt. So don't forget those derivatives, because those values, dy dt and dx dt, mean something. Find an equation connecting the variables, right? We use Pythagorean theorem. Differentiate this equation, solve for the derivative so that that will give you the unknown rate. So big thing here, identifying all variables, okay? And then again, finding an equation. And that is not going to be easy. However, they typically kind of give you an idea, you're using a triangle. So the big thing is you need to really make that sketch to figure out what it is you're even dealing with. So let's take a look at a rock thrown into a still pond. And so if you think about a rock being thrown into a pond, it's a circular ripple. And so what do you have? A circle, right? Concentric circles. And if you know anything about circles, the area of a circle is pi r squared, right? The circumference is equal to pi times diameter, or 2 pi r. And if the radius, here's a problem, sorry. If the radius of the ripple is increasing at 2 feet per second, because there's 2 pieces of information at feet per second, we know that we're dealing with a rate. Okay, so how fast is the area changing when the radius is at 10 feet? So here it's giving you the formula, A equals pi r squared. And so the radius is changing, and so that is dr dt, and that is 2 feet per second. Okay, and so let's find out how fast this area is changing when the radius is 10 feet. Okay, so again, we're drawing a picture, right? Make a drawing first, number 1 thing to do. So here's our picture. R is our radius, capital R is our radius, capital A is our area. And we found earlier that dr dt is 2, r is 10. And so we're going to find the derivative of the area. And so r is our variable. We're going to take the derivative with respect to t. Okay, and so our derivative is dA dt, right, with respect to t. And then pi, because this is a constant, okay, and then you just use the normal power rule here. So this is 2r dr dt. Okay, so now we want to get dA dt by itself, and it is for the most part. So really it's, if you wanted to be technical, 2 pi r dr dt. And we have all of this information. You have r, which is 10, you have dr dt, which is 2, and so our answer here, the area changes at a rate of 40 times pi, which is about 40 times 3, or about 120 feet, I believe, per second. So related rates in business. Suppose that a company, again, we're talking about cost and revenue. Our cost function is equal to 5,000 plus 2x. Okay, we're going to figure out what that 5,000 and what that 2x is. And their revenue is 10x minus 0.001x squared. So the production output in 1 week is x radios. So x is the amount or the number of radios produced. Now, if production is increasing at the rate of 500 radios per week, okay, so X is the number of radios and we have a rate at which those radios are produced, then most likely the 500 radios is dx dt, right, is equal to 500 radios. And when production is at 2,000 radios, so X needs to be 2,000. Find the rate of increase in cost and in revenue. So again, we're going to take the derivative of the cost function, the derivative of the revenue function. So there are really two related rate problems, one involving the cost, X and T, and one revolving the revenue, X and T. So let's differentiate both functions with respect to time and separately. So let's do cost function first. Okay, so 5,000 plus 2x. So again, the derivative of 5,000 is 0, right? The derivative of 2x is just literally this, 2 dx dt. So the derivative is right here. dc dt is equal to 2 dx dt. And we have both of those informations. Okay, so the cost is increasing at a rate of $1,000 per week for every 500, I believe 500 radios. That is as we make an increase of 500 radios. Now for revenue, we're going to take the derivative of this right here. Now again, these are all power rules, right? Exponential rules. The derivative of 10x is 10 dx dt. You can see that here. And then this is, remember, that 2 is going to be multiplied down next to 0.001. That gives us 0.002. And then x to the 2 minus 1 is just x. And then dx dt. And we again have all of this information. dx dt is 500, right? X is 2,000. dx dt is 500. And so the revenue will increase at $3,000 per week.